Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we have another topic of chapter number 13, that is galvanometer. So, galvanometer is defined as the device which is used to detect current is called galvanometer. Okay, so basically galvanometer is a detector for current. Okay, and galvanometer can be used to determine the small amount of current also. So remember, galvanometer is a very sensitive device. Very sensitive device. It can measure it can detect very small current. So that is why it is a very sensitive device. Okay. There are two types of galvanometer. One is the pivoted coil galvanometer, and another is lamp scale method galvanometer. One is the pivoted coil galvanometer, the other is lamp scale method galvanometer. Okay. Now, first we are studying pivoted coil galvanometer. So look at the construction of pivoted coil galvanometer. So first we are studying pivoted coil galvanometer. Okay, look. This pivoted coil galvanometer consists of U-shaped magnet. This is a U-shaped magnet. Okay. And there is a cylinder. Why the cylinder is placed? The cylinder is placed to increase the moment of inertia of the coil. Okay. For the continuous torque, we should increase the moment of inertia. Look at the coil wrapped from the coil. There are a certain number of turns or windings from this cylinder. So this is the number of turns. How many turns are there? There are n number of turns are there. Okay. And there is an arm which is called the axis of rotation, and there is a spring. This spring produces the restoring torque. Okay. Now there is a screen which can be seen easily when we have galvanometer practically, and there is a needle on the screen placed which is placed on the zero deflection. Okay. Initially the needle is at zero deflection. This needle is attached to the axis of rotation. Okay. Now look, if we connect, this is all about construction. If we connect the current through these wire, now we want to detect the current, where there is a current or not. So look at here. So in this bundle of wire, the current will moving up. So if the current is moving up, here the current is moving towards right, here the current is moving down, at this end the current is moving towards left. But at this end and at this end there will be no magnetic force, because this current is moving towards left and the magnetic field is acting towards right. So both are anti-parallel, so no magnetic force will be acting at this end. Look at this end. Here the current is moving towards right and the magnetic field is also acting towards right. So both have the same direction, the angle between them is 0, so no magnetic force will be acting on this end. Okay. Now look at this end. Here the current is moving up. So if the current is moving up, so a maximum magnetic force. So look at the direction of magnetic force. The current is moving up. The magnetic field is pointing towards right. So the magnetic force is acting vertically downward. So here the magnetic force is acting vertically downward. And look at this end. Here the current is moving down. If the current is down and the field is towards right, so the magnetic force is out of the page. So at this end the magnetic force is out of the page, at this end the magnetic force is into the page. So the coil will be rotated. If the coil is rotated, so this needle will give the deflection. So current is detected by this galvanometer. So this is basically the phenomena of galvanometer, that how it can detect a very small current. So look at the applied torque. Applied torque is equal to Nayab cos theta. We already studied in the previous topic this equation, torque is equal to Nayab cos theta. This is the applied current, applied torque, because it is produced by the applied current. We apply the current and torque is being produced. So this torque is actually the applied torque. Okay. Now if the needle comes over here, now we disconnected the current. If we disconnect the current, so we want that the needle should come to its original position at zero deflection. So that is why we connect a spring with the coil. So this spring will rotate it back the coil, and this needle will comes to its original position. For example, I'm giving you an example. If the current is moving in the coil, and this current gives 5 rotation clockwise, so the spring will gives 5 rotation anti-clockwise to bring this needle at its original position. So what is the purpose of this spring? To produce the restoring torque. As we place the spring in our doors, why we place spring in our doors? Because we want to produce the restoring torque. So that is why we placed springs in our doors. Okay. Now look here, these are the number of divisions on the screen. So if the coil rotated, so the needle will cover the number of divisions. So uh, in this rotation, we call it angular displacement. If there is one rotation, the angular displacement is 2 pi radian. If there are two rotation, the angular displacement are 4 pi radian. If there are three rotation, the angular displacement will be 6 pi radian. So theta is actually the angular displacement. Okay. Now theta torque is equal directly proportional to angular displacement. Means if the spring gives two revolutions, angular displacement is 4 pi. If the spring gives 6 revolution, the angular displacement will be 12 pi. So it means that this angular displacement, this spring gives the torque, and which will cover angular displacement. So torque and angular displacement are directly proportional. So if the spring rotated the coil for 5 times, so the angular displacement will be 10 pi radian. So it means that if the spring rotated the coil for 20 rotations, so the angular displacement is 40 pi radian. So it means that the spring will give the torque to the coil, and this torque will produce angular displacement in the coil, and it will cover number of divisions. Okay. Now these are both are directly proportional, and if you remove the proportionality sign, so we will place a constant that is called C. So this is called the restoring torque produced by the spring, and this is called the applied torque produced by the applied current. Okay. Now both the torque are equal. Why? Because if the current rotated for the 5 rotation, so the spring will also be rotated back for the 5 rotation. So both the torques are equal. So compare both the equation. So we will get Nayab cos theta is equal to C theta. So divide nab cos theta on both sides. So we will get I is equal to C theta divided by nab cos theta. Okay, this is the equation we have. This equation is called the sensitivity of galvanometer. This equation is called the sensitivity of galvanometer. Okay. This is the sensitivity of galvanometer. What is C? C is called the restoring torque per unit twist, or per unit angular displacement. Restoring torque per unit angular displacement. Okay. Or per unit twist, you can say. What is this C shows? This C shows the stiffness of the spring. Stiffness means hardness of the spring. If the spring is hard, stiff, so the value of C will be maximum. So if the spring is soft, the value of the C will be minimum. So the spring shows the stiffness of the spring. So suppose if we place a soft spring, so it will detect the small current more sensitive, Both are directly proportional. Both are directly proportional. So if we place a soft spring, the value of C will be smaller, and it can detect the smaller current, so it will be more sensitive. Look at the number of turns. It is inversely proportional to current. If the number of turns are larger, current detect will be smaller, more sensitive. If the area of the coil is larger, current detect will be smaller, more sensitive. And look at this magnetic field. We should place a radial magnetic field rather than uniform. Uniform magnetic field is weaker, while the radial magnetic field is stronger. So we should place the radial magnetic field. So if the radial magnetic field we place, so radial magnetic field is stronger, so the current detect will be smaller, more sensitive. So this is all about the sensitivity of the galvanometer. So this is the pivoted coil galvanometer. We have already discussed it. Okay, now another thing is lamp scale method. Another galvanometer, the type of galvanometer is lamp scale method. Okay, in this galvanometer there is no needle, so the deflection it shows is because of light only. Okay, suppose there is a stand. Okay, there is a screen. This zero deflection, and these are the number of divisions on the screen. Okay, and this is the mirror, and this is the rectangular coil. Okay, and this is the spring which produces restoring torque. So we will place the coil into the magnetic field. So we placed a coil into the magnetic field, and this is the mirror. We know that mirror gives the reflection, and this is the light source. Okay, this is the screen, this is the light source, okay. Now light fall on the mirror, and the mirror gives the reflection on the screen, and the reflection fall and the zero deflection. Zero deflection shows no current. Okay, now if we connect the current to the coil, so here at this end there will be magnetic force, and at this end there will be magnetic force. For example, if I want to find the direction of this magnetic force, so the current is moving up, so the middle finger should be acting up. So look at the middle finger which is acting up, and the magnetic field is acting towards right, so the magnetic force should be acting downward. So this is the middle finger, no, this is the thumb. The thumb is acting downward, so the magnetic force is vertically down, means into the page. And look at this current. This current is acting downward, so the middle finger should point towards down, and the first finger acting towards right. So look at the thumb is vertically up. So at this end the magnetic force is out of the page, at this end the magnetic force is into the page, so the coil will be rotated. If the coil is rotated, the mirror will be rotated. If the mirror is rotated, the light will travel on the screen, so which shows the deflection. So it means that this galvanometer will also shows deflection when the light travels on the screen, so it means that the current detected. So this is the deflection given by the lamp. So this is all about the two types of galvanometer. If you have any queries, you can ask in comment section or in WhatsApp group. Okay, take care. Allah Hafiz.